Section 680.24 of the National Electrical Code, specifically the 2014 edition, addresses wiring methods for swimming pool lighting. The code states that wiring from the transformer to the pool lighting fixture must be installed in a rigid non-metallic conduit and should not exceed 3 feet from the transformer enclosure to the pool lighting fixture. The interpretation of the word directly within this section is crucial. According to the code, it is permissible to have a series of junction boxes that are not specifically listed for swimming pool use, provided that the last junction box in the series, the one directly connected to the light assembly, is indeed listed for such use. This allows for installations that include an intermediate junction box positioned between the transformer enclosure and the listed pool junction box. However, the code explicitly prohibits wiring directly from the transformer to the light without any junction box at all. This practice is not in compliance with the NEC requirements for swimming pool lighting. The rationale behind requiring a listed junction box near the pool light is to ensure a safe and reliable electrical connection in a potentially hazardous environment. Swimming pools present unique electrical hazards due to the presence of water, which can conduct electricity. Listed junction boxes are designed and tested to withstand these conditions, providing protection against water ingress, corrosion, and other factors that could compromise the integrity of the electrical system. Failing to use a listed junction box could result in electrical shock hazards for swimmers and other individuals in the vicinity of the pool. The 3-foot limitation on the conduit run from the transformer to the light is also intended to minimize the risk of voltage drop and ensure proper operation of the lighting fixture. A longer conduit run could result in a significant voltage drop, reducing the light output and potentially damaging the fixture. The requirement for rigid non-metallic conduit is intended to provide a durable and corrosion-resistant pathway for the wiring. Non-metallic conduit is also non-conductive, further reducing the risk of electrical shock hazards. In summary, while the NEC allows for the use of non-listed junction boxes in the wiring run from the transformer to the pool light, it mandates that the final junction box directly connected to the light assembly must be listed for swimming pool use. Direct wiring from the transformer to the light without any junction box is strictly prohibited. Compliance with these requirements is essential to ensure the safety and reliability of swimming pool lighting systems. When planning and installing swimming pool lighting, firstly, always consult the latest edition of the NEC and any applicable local codes. Secondly, ensure that all electrical work is performed by a qualified and licensed electrician. Thirdly, use only listed and approved components for swimming pool applications. Fourthly, carefully follow the manufacturer's instructions for installation and maintenance. Fifthly, regularly inspect the electrical system for any signs of damage or deterioration. Sixthly, immediately address any electrical issues to prevent potential hazards. It's also crucial to understand the definitions and requirements outlined in other sections of Article 680 in the NEC, such as those pertaining to bonding and grounding of metallic parts. Bonding and grounding are essential safety measures that help to minimize the risk of electrical shock hazards in and around swimming pools. Furthermore, ensure that all electrical equipment used in swimming pool applications is properly rated for the environment. This includes factors such as water resistance, corrosion resistance, and temperature rating. The electrical system should also be protected by ground fault circuit interrupters, or GFCIs, which are designed to detect small electrical leaks and quickly disconnect power to prevent electrical shock. Proper maintenance of the swimming pool electrical system is also essential for ensuring continued safety and reliability. Regularly inspect the wiring, conduit, junction boxes, and lighting fixtures for any signs of damage or deterioration. Replace any damaged or worn components promptly. It is also important to keep the area around the electrical equipment clean and dry. Avoid storing chemicals or other corrosive materials near the electrical system. By following these guidelines and adhering to the requirements of the NEC, you can help to ensure a safe and enjoyable swimming pool experience for everyone. Always prioritize safety when working with electricity, and never attempt to perform electrical work unless you are qualified and knowledgeable about the relevant codes and standards. Furthermore, understanding the specific requirements for different types of swimming pools, such as permanently installed pools, storable pools, and spas, is also crucial. Each type of pool may have unique electrical requirements, so it is important to consult the NEC and any applicable local codes to ensure compliance. For example, storable pools, which are typically smaller and portable, may have less stringent electrical requirements than permanently installed pools. However, even with storable pools, it is important to follow basic electrical safety practices such as using GFCIs and keeping electrical equipment away from water. Spas, which are often heated and equipped with jets, may have additional electrical requirements related to bonding and grounding of metallic parts. It is also important to consider the location of the swimming pool when planning the electrical system. Pools located near overhead power lines may require additional clearances to prevent electrical hazards. The NEC specifies minimum clearances between swimming pools and overhead power lines, and it is important to adhere to these requirements. In addition to the technical aspects of swimming pool electrical systems, it is also important to consider the aesthetic aspects. Lighting can play a significant role in the overall ambience of the pool area, and it is important to choose lighting fixtures that are both safe and visually appealing. There are a variety of lighting options available for swimming pools, including underwater lights, above-ground lights, and landscape lighting. Underwater lights can create a dramatic effect and enhance the visibility of the pool at night. Above-ground lights can be used to illuminate the pool deck and surrounding areas. Landscape lighting can be used to highlight trees, shrubs, and other features in the pool area. When choosing lighting fixtures for swimming pools, it is important to select fixtures that are specifically designed for this purpose. These fixtures are typically made of corrosion-resistant materials and are sealed to prevent water ingress. It is also important to ensure that the fixtures are properly grounded and bonded to prevent electrical shock hazards. In conclusion, swimming pool electrical systems require careful planning, installation, and maintenance to ensure safety and reliability. By following the requirements of the NEC and any applicable local codes, you can help to create a safe and enjoyable swimming pool environment for everyone. Remember to always prioritize safety when working with electricity, and never attempt to perform electrical work unless you are qualified and knowledgeable about the relevant codes and standards. Ground fault circuit interrupters, or GFCIs, are essential safety devices that should be installed in all swimming pool electrical circuits. GFCIs are designed to detect small electrical leaks and quickly disconnect power to prevent electrical shock hazards. GFCIs should be installed in all branch circuits that supply power to swimming pool equipment, such as pumps, filters, heaters, and lighting fixtures. GFCIs should also be installed in all receptacles located within 20 feet of the pool. Regular testing of GFCIs is essential to ensure that they are functioning properly. GFCIs should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Bonding is another important safety measure that helps to minimize the risk of electrical shock hazards in and around swimming pools. Bonding involves connecting all metallic parts of the pool and its surrounding structures to a common grounding point. This creates a low impedance path for fault current to flow back to the source, which helps to trip the GFCI and energize the circuit. Metallic parts that should be bonded include the pool reinforcing steel, the pool equipment, and any metallic fences or structures located within 5 feet of the pool. The bonding conductor should be sized according to the requirements of the NEC. Grounding is the process of connecting the electrical system to the earth. This provides a path for fault current to flow back to the source in the event of a ground fault. The grounding electrode should be a ground rod, a ground plate, or a metallic water pipe. The grounding electrode conductor should be sized according to the requirements of the NEC. The electrical system should be inspected regularly by a qualified electrician to ensure that it is properly grounded. Surge protection is another important consideration for swimming pool electrical systems. Surges can damage sensitive electronic equipment, such as pumps, filters, and heaters. Surge protective devices, or SPDs, can be installed to protect these devices from surges. SPD should be installed at the service entrance and at any subpoles that supply power to swimming pool equipment. Proper maintenance of the swimming pool electrical system is essential for ensuring continued safety and reliability. Regularly inspect the wiring, conduit, junction boxes, and lighting fixtures for any signs of damage or deterioration. Replace any damaged or worn components promptly. It is also important to keep the area around the electrical equipment clean and dry. Avoid storing chemicals or other corrosive materials near the electrical system. If you notice any electrical problems with your swimming pool, such as flickering lights, tripping circuit breakers, or tingling sensations in the water, contact a qualified electrician immediately. Do not attempt to repair electrical problems yourself, as this could be dangerous. By following these safety tips, you can help to ensure a safe and enjoyable swimming pool experience for everyone. Always prioritize safety when working with electricity, and never attempt to perform electrical work unless you are qualified and knowledgeable about the relevant codes and standards. In addition to the technical aspects of swimming pool electrical systems, it is also important to be aware of the potential hazards associated with swimming pool chemicals. Swimming pool chemicals can be corrosive and can damage electrical equipment. It is important to store swimming pool chemicals properly and to avoid spilling them on electrical equipment. If chemicals are spilled on electrical equipment, clean them up immediately with a damp cloth. Never use water to clean electrical equipment, as this could create an electrical hazard. Swimming pool electrical systems are complex and require careful attention to detail. By following the requirements of the NEC and any applicable local codes, and by taking the necessary safety precautions, you can help to ensure a safe and enjoyable swimming pool experience for everyone. Also, remember that any electrical work near or around a pool has to be performed by a qualified licensed electrician. They will also know any local amendments and adjustments to the code that could be in effect that are specific to the area. If any pool lights are underwater, even low voltage ones, a ground fault circuit interrupter or GFCI is required. These must be tested monthly. Always verify and adhere to the latest published NEC guidelines.